Hello everyone. Today we're gonna solve this problem, the palindrome linked list problem. This is the problem from Leetcode, and this is like an update version of the reverse linked list problem. So with this problem, if we have a linked list, we have to check whether or not this linked list is a palindrome linked list. So how can we do that? First of all, we can create another linked list, and then we reverse the linked list to see whether or not they have the same order. And what we're gonna do is we create a copy version first, and then we reverse all the connection of the linked list. So we're gonna have something like this. And then we start from the head of two lists, head 1 and head 2, and then we check whether or not if we look through all of the elements in these two linked lists, they will have the same value. For example, if we start from this and this, we check whether or not these two are the same value. If they are the same value, we continue to check the second one until we reach the end of the linked list. So we check 1 and 1, they are equal, so we check 2 and 2, 2 and 2, and 1 and 1. And if they have the same values, they are two versions of just a linked list, so they are palindrome linked list. And we also can just use one linked list instead of the two linked lists by we can just reverse the first half or the second half of the linked list. So in this case, I suppose I reverse the second half of the linked list. So which means that for this, we start from this one and we reverse the connection from 2 to 1, and we change it to 1 to 2. So after that, we will start from the end of the linked list, which is a new head right here. And then we double check whether or not we can have the same linked list if we start from the starting point and the ending point. If you can imagine that like we are checking a string like this, instead of reverse all of the string, we can just reverse the second half of the string, right? And we will check whether or not the reverse version of the second half is the same with the first half. So that's basically what we're gonna do. And how can we do that? So first of all, I will create a function to get the length of the linked list first, because we want to check the second half, right? So first of all, we need to get the length of the linked list. So let's say the length of the linked list is n. And imagine that we already have the function to get the length of the linked list, right? So right here we have current node. We return something here. Yep. Okay, and after we have the length of the linked list, we need to move the pointer until the end of the linked list. So I will create a position of the half. Let's say we're gonna find the starting point of the second the second half. So which means that we have n plus 1 divided by 2, and then we reverse the second half. But we need to move to the node where the second half starting. So let's say I will have a function called traversal from head to the position we need. Yeah, we have this function, and I will have a head of the second half, a new head, just the second head, right? Will be equal to traversal of the head and the start of the second half, starting point of the second half, right? And this one is the lead node, and this one is integer. So, and then we will look through each of the element after we reverse, right? So I need to reverse it first. Yep. Let's say we already have this function, and yeah, and then we'll get the length should be equal to this, and if we have the length equal to the length is odd, we need to decrease the current length, and then we can just compare the length of the first half and the second half. And each step we will compare the value of the first half and the second half. If they different, obviously they are not palindrome. And then we move to the next node for head and for second head. And finally, we return to here, right? And next, we have to implement all three functions. If you haven't seen the reverse linked list yet, you should check out my video. I will put it down at the end of the video. First, to get the length of the linked list, I will look through all of the nodes. So this one, I will look until the current node is not null pointer, and we increase the length of the current node would be equal to the next node, and then we'll return the length here. And let's say this one is the number of steps. To travel from the head node by step, we just use a y step decrease by 1. We have the current node, which is the head node, which would be equal to next node, and we just return the head node right here. Actually, we should put in the current node. It would make more sense. Yeah. And then to reverse a linked list, we are gonna implement exactly what we used to do for the reverse linked list problem. So first of all, we're gonna check whether or not our linked list have more than one element. So we can just check if the head, this one should be head, equal to null pointer, or the next node equal to null pointer, which means that this one is the length less than one, less than or equal one. We just return head right here. Otherwise, we will have this node, the current would be equal half, and we store the previous node as well. After that, we have a while function right here to look through all of the nodes in our linked list. And then we get the next node should be equal to current.next. And then we will redirect the current connection from current.next to the previous node. And then we will assign the previous node to current node, and the current node would be equal to the next node. And finally, we return the previous node right here. So yeah, I think that's all for our implementation. And for the time complexity, it should be equal to O(n), and the space complexity should be equal to O(1). Right. It looked good to me. And finally, we submit it to see how it goes. Yeah, it's correct. So that's all for this palindrome linked list problem. If you haven't seen the reverse linked list problem yet, check out the link in the right side to see it. Thank you.